Hey guys, welcome back to the CAIE lab, and today we're going to be mastering one of the most important topics of IGCSE and A-levels chemistry, organic chemistry. It's actually a branch of chemistry that deals with the study of hydrocarbons and their derivatives. Hydrocarbons are all those compounds that are made up of hydrogen and carbon only. Derivatives are all those compounds that contain another element other than hydrogen and carbon. And we have a list of organic compounds here. Firstly, we have C2H6. As you can see, there are only two elements, carbon and hydrogen, so they will be considered as the hydrocarbon. However, we have here C5H11OH. Here we have another element, oxygen, so it will be considered as the derivative of hydrocarbon. If any compound contains more than two elements, then it will be considered as the derivative of hydrocarbon. Alright, furthermore, we have some important points and characteristics of a carbon atom. Carbon can form over 4 million of compounds. Carbon belongs to group 4, so it makes a total of 4 bonds. And these bonds can either be a single covalent bond, double covalent bond, or a triple covalent bond. As you can see here, we have only one line that represents the single covalent bond. We have two lines that will represent the double covalent bond, and we have three lines that will represent the triple covalent bond. Alright, so another thing is that there is counting in organic chemistry that is related to the number of carbon atoms in a compound. Counting in organic chemistry involves around number of carbon atoms. Number of carbon atoms along with their names are listed here. This is a whole series, and it's more preferable if you memorize them so you're able to name the organic compounds further in the organic chemistry. Alright, let's read them. So a compound with one carbon atom is named as meth, second is eth, third is prop, fourth is bute, fifth is pent, sixth is hex, seventh is hept, eighth is oct, ninth non, and 10th is dec. Okay, so furthermore, types of hydrocarbons. Hydrocarbon is broken down into two basic components, saturated hydrocarbon and unsaturated hydrocarbons. Now, what is actually saturated hydrocarbon? It's basically a compound that contains all the carbon-carbon single bonds. We have an example of alkanes, and unsaturated hydrocarbons are those compounds which do not contain carbon-carbon single bonds, but they contain either a double covalent bond or a triple covalent bond. We have example of alkenes as a double covalent bond and alkynes as a triple covalent bond. However, alkynes are not in our syllabus, so we're not going to consider it further. Okay, now let's talk about alkanes. It's actually a type of hydrocarbon. We're going to study about its chemical, its physical properties, and all of their naming and further things. So, what are actually alkanes? They are hydrocarbons, they are saturated hydrocarbons, and they have a general formula that you must remember. CnH2n plus 2. It's actually helpful because it is used to define and write the molecular formula of all the alkanes. Another thing is that alkanes are named and their name ends with ane. Now, let's take an example of methane. Now, you can recognize something that the first part is from the series of counting in organic chemistry. First part represents this, meth, and the second part is of the alkanes, which is ane. Methane. Now, let's use the general formula of the alkanes to define and write the molecular formula of methane. Methane, meth means one carbon atom, so we're going to write the formula as C and H2 multiplied by 1 plus 2. Now, as you can see here, this N, which represents the number of carbon atoms, so we are replacing this N with 1 because we are talking about methane. Meth means 1, so 1 is the number of carbon atom, and therefore we are replacing N with 1. And after solving the whole equation, we'll get to know that the molecular formula of methane is CH4. I hope you've understood how to use the general formula to write the molecular formula and to write the name of the compound. Alright, now here we have a whole series of the alkanes, their names, their molecular formulas. So I think you must remember and memorize all of these names so that you're able to instantly figure out the compounds in your exams. Alright, now let's see how are we able to write the structural formula and molecular formula of all the alkanes. It's actually very basic. So now you are able to write down the molecular formula as we have to use a general formula for it. I'm going to show you how to write the structural formula for it. Firstly, we have here methane as an example. Methane, which has meth, which means one carbon atom. So we're going to write down firstly the number of carbon atoms that we have in our compound. Now, as you can see, methane contains only one carbon atom, so we're just going to write 1C. Alright, now the second step is that you have to create all the bonds of the carbon atom. Carbon atom is actually a group 4 element in the periodic table, so it makes 4 bonds. Let's draw the lines that represent the bond. We have to make 4 lines, and they're going to be the single lines because alkane is a saturated compound and it contains all carbon-carbon single bonds. Alright, so we have made all the bonds. Now let's write down the H element along with each line. 1H, second H, third H, fourth H. And this is how we are able to write down the displayed structural formula. Let's do this with the ethane. I've written here. Now, first step is that you have to write down how many carbon atoms are in the compound. Ethane means there are 2 carbon atoms in the compound, so we're going to write down 2 C's. After that, we're going to draw a slash between them to complete their bond. Then, now let's see this first C. Now we have to complete the 4 bonds of it. 1 is already made, so let's make the 3 other. 1, 2, and 3. Now 4 bonds of it is completed. Let's see the other C. 1 bond is already made, so we have to do the same thing, make 3 bonds again, and with each line then we have to write the H. And this is how we're able to write the structural formula of ethane too. The same thing is we're going to do with the propane, write down the number of carbon atoms, then completing their bonds, and after that writing H along with them. Okay, so take a moment to solve this example on your own. Pause the video right now. Then, when you're ready, resume it to see the solution. Now let's solve it together. Firstly, I'm going to write down the molecular formula of octane using the general formula CnH2n plus 2. As n here is equal to 8, I'm going to put in the value of n as 8, C8H, 2 bracket 8 plus 2, which gives us C8H18. Now let's write down the structural formula. Firstly, you have to write down the number of carbon atoms present in the compound. I have 8 here, so I'm going to write down 8 carbon atoms. 1, 2, 3, 4, 5, 6, 7, and 8. Now let's complete the bond of each carbon atom. This C has 1 bond already made, so I'm going to complete the rest of the 3. This has 2 bonds to be made. Alright, I'm completing bonds of each carbon atom. I've completed it. So now let's write down the H element along with each bond. I have 3 here for 5th, 6th and 7th, 8th and 9th, 10th and 11th, 12th and 13th, 14th and 15th, 16th and 17th, and then lastly the 18th. This is how I've completed the structural formula of octane. I have 8 carbon atoms like here, and I have 18 H element hydrogen atoms like this. Alright, so now you will be able to complete and write down the structural formula and molecular formula. Now let's focus upon this condensed structural formula. It's actually the short form of the displayed structural formula. I'm going to show you how to write it down. So basically, you're going to just write this whole thing in a simpler way. Condensed structural formula for C is just simply CH4 because there is no other carbon atom, so we don't have to separate anything. But here we have ethane, and we have to separate both of these carbon atoms. So let's draw a line in between them. And firstly, let's focus upon this part. It has 3H with it, so we're going to write CH3. And then we have a line between them. We're going to draw a line here. And then we have, again, C with 3H. We're going to write CH3. And this is how we've written down the structural formula. Same thing we're going to do with propane. And, okay, let's show another example of butane. So here we have the structural formula of butane. Let's separate all of the carbons. All right. We have 4 carbons to be separated. Firstly, let's focus upon this part. Here, C is with 3H. We're going to write down CH3. Here, C is with 2H. We're going to write CH2. Here, C is with 2H again. We're going to write CH2, and C is with CH3. Now, as you can see that between 2 CH3, we have 2 CH2. To further shorten it out, so we're going to write CH2 in bracket with a 2 outside, representing that there are 2 CH2 between the CH3s. Okay, now, again, take a moment to solve this example on your own. Pause the video right now, then resume it when you're ready to solve the solution. Okay, so let's solve it together. We have to separate these carbons together. I'm gonna just put in the lines between them. This C has 3H to be written along with it, so it's gonna be CH3. One line. We have C with 2H, CH2, another CH2, another CH2, another CH2, and another CH2. Then lastly, another CH2 with a CH3. So in total, we have 6 CH2s with 2 CH3. To further shorten out, I'm going to write CH3 with the bracket CH2, 6 outside because we have 6 CH2s, so we're going to just write it like this. And this is how we have written down the structural formula, condensed structural formula of octane. So another topic to discuss is the physical properties of alkanes. The first physical property of alkane is that its melting point and boiling point increases down the family due to the increase in the molecular mass. Now, there is an increase in the molecular mass because the number of carbon atoms are increasing down the family, so a high amount of energy is required to reach the melting point and the boiling point. Second thing is that the density increases down the family due to increase in the molecular mass. This has the same reason here because the number of carbon atoms are increasing, so there are more amount of particles present per unit time. Third thing is that viscosity, which is the thickness of a liquid, increases down the family due to increase in the molecular mass. Fourth thing is that the flammability decreases down the family due to increase in carbon atoms. And finally, alkanes are insoluble in water, but soluble in organic solvents such as tetrachloromethane and benzene. Now, another thing to focus upon is the chemical properties of alkanes. In total, there are 2 chemical properties of alkanes. The first chemical property is the substitution reaction, in which a hydrogen atom in an alkane is replaced by a halogen atom, only a halogen atom. Second one is the combustion reaction, in which alkanes react with oxygen to produce carbon dioxide and water with evolution of heat and light. The combustion reaction is of actually 2 types, complete combustion and the incomplete combustion. The complete combustion occurs in the sufficient supply of oxygen, whereas the incomplete combustion occurs in the insufficient supply of oxygen. So, the products in the complete combustion are the carbon dioxide and water, and in the incomplete combustion, the products are carbon monoxide and water. So let's move on to the substitution reaction of alkanes. Let's take an example of this equation. Firstly, this is methane, which reacts with chlorine in the presence of UV light because it is a photochemical reaction, and the products are monochloromethane and hydrochloric acid. Why it is named as monochloromethane? Because there is only one chlorine present, and mono means one, so it's named as monochloromethane. Second example, we have here the trichloromethane. We have 3 carbon chlorine atoms, so we're going to name it trichloromethane, which reacts with chlorine in the presence of UV light to form tetrachloromethane and hydrochloric acid. Here we have 4 chlorine atoms, so it's named as tetrachloromethane, where tetra is meant by 4. And this is the end of the reaction because all the hydrogen atoms are replaced by the chlorine atoms. Here we have another example. We have here monochloromethane, which reacts with chlorine in the presence of UV light to form dichloromethane and hydrochloric acid. So this was all for today. I hope you liked the video and understood the concept. Don't forget to hit the bell icon and subscribe to my channel. Let's meet in another video.